Hello students, our today's topic is coordinate geometry. Here two mutually perpendicular lines x o x dash and y o y dash. This is x axis and this is y axis. The point of intersection is denoted by O. Here in x axis, in each and every point on x axis, value of y is 0, like x comma 0. Similarly, in each and every point on y axis, the value of x is 0, like 0 comma y. So first of all, two important notes. Any point on x-axis is x comma 0. Similarly, any point on y-axis is 0 comma y. x-axis को जुनसुकै point को y को भ्यालु 0, सो हामी यसलाई x comma 0 ले अथवा a comma 0 ले डिनोटेट गर्छौं. Similarly, y-axis को each and every point मा x को भ्यालु 0, so it is denoted by 0 comma y or 0 comma b. The distance formula 1 distance formula. Suppose P x1 y1 be any point and another point Q x2 comma y2. Distance between PQ is D, and D is equal to over root x2 minus x1 whole square plus y2 minus y1 whole square. Let AB be the straight line and AB makes an angle theta with positive x-axis. Then tan theta gives a slope of line AB. If a line AB makes an angle theta with positive x-axis, then tan theta gives the slope, the line AB. Now slope of line joining two points. Slope of line joining two points P x1 comma y1 and Q x2 comma y2. The slope is denoted by m. The slope of PQ is y2 minus y1 divided by x2 minus x1. Slope m is equal to y2 minus y1 upon x2 minus x1. Now section formula or division formula. A. Internal division. Internal division. P divides AB in the ratio M1 is to M2. Then we have for internal division, X is equal to X2 M1 plus M2 X1 divided by M1 plus M2. Similarly, Y is equal to Y2 M1 plus M2 Y1 divided by M1 plus M2. For external division, here P is outside. Then we have X is equal to the P divides AB in the ratio AP is to BP, AP is to BP, M1 is to M2. Then X is equal to X2 M1 minus M2 X1 upon M1 minus M2. Similarly, Y is equal to Y2 M1 minus M2 Y1 upon M1 minus M2. External र internal मा plus हुन्थ्यो, external मा minus. Now see midpoint formula. The P is the midpoint of AB. Then we have X is equal to X1 plus X2 by 2 and Y is equal to Y1 plus Y2 by 2. Midpoint formula. For centroid formula, here ABC be a triangle. The AD, B and CF are medians and their point of intersection is G, which is called centroid. Centroid formula, X is equal to X1 plus X2 plus X3 divided by 3. Similarly, Y is equal to Y1 plus Y2 plus Y3 divided by 3. 5. Area of triangle. Area of triangle. Area of triangle is equal to 1 upon 2 x1 y1 x2 y2 x3 y3 x1 y1. Area of triangle 1 upon 2 x1 y1 x2 y2 x3 y3. Repeat again x1 y1. First column लाई repeat गर्ने. Then this is 1 upon 2 x1 times y2. x1 times y2 minus x2 times y1 plus similarly x2 times y3 minus x3 times y2 plus x3 times y1 minus x1 times y3. Which gives the area of triangle. Now, equation of straight lines. A. Slope intercept form. Here, AB makes an angle theta with positive x-axis. If we take tan theta, then tan theta gives a slope of straight line. Now, equation of straight lines. A. Slope intercept form. slope intercept form. Here AB makes an angle theta with positive x-axis. So slope of AB is tan theta. Tan theta gives the slope of AB, which is denoted by m. And AB makes y-intercept as C. Then equation is y is equal to mx plus c. Here m is slope and y-intercept c. Y-intercept. B. Double intercept. Double intercept form. Here AB makes an intercept A on x-axis and B on y-axis. So x-intercept is A and y-intercept is B. Then equation in double intercept form is x by A plus y by B is equal to 1. C. Normal or perpendicular. Here AB is the straight line such that the length of perpendicular from origin on the straight line AB is OM, which is denoted by P. Length of OM is P, and OM makes an angle alpha with positive x-axis. Then the equation of AB in normal or perpendicular form is x cos alpha plus y sin alpha is equal to P. Here P is length of perpendicular from origin on the given line AB, and alpha is the angle made by OM with x-axis. D. Point slope form. Point slope form. We have one point and slope are given. One point and slope are given. Then equation is y minus y1 is equal to m times x minus x1. Like any point x1 y1 and slope is m. A 2 points form. In this case 2 points are given, x1 and y1, x1 comma y1 and x2 comma y2. Now equation of line joining x1 y1 and x2 y2 is y minus y1 y2 minus y1 upon x2 minus x1 times x minus x1. If we replace m by, that is slope, by y2 minus y1 upon x2 minus x1, then we get 2 points form. एउटा point slope दियो, यसलाई use गर्ने, दुईटा point दियो, यसलाई use गर्ने. We take one example. Find the equation of the line making an angle of 60 degree with the positive x-axis and cutting an intercept 3 from the y-axis. Solution. I have a line AB which makes an angle 60 degree with positive x-axis and cutting an intercept 3 from the y-axis. This is 3 unit. Here slope m is equal to tan 60. Value of tan 60 is root 3. The y-intercept c is equal to 3 units. Then the equation of straight line. Equation of straight line in slope intercept form is y is equal to mx plus c, or y is equal to m. We have m is root 3 plus c is 3, or this is root 3x minus y plus 3 is equal to 0, which is the required equation. We take another example. Find the equation of the line which bisecting the angle between the axes. Here x-axis and y-axis. By the equation, straight line bisecting the angle between the axes. Then we have two cases. One is this 45 and 45. Case 1. If AB makes an angle 45 degree with x-axis, then slope of AB is tan 45 degree. This is 1. Since AB passes through the origin, so there is no y-intercept. C, that is C is equal to 0. The required line is y is equal to mx, or y is equal to m is 1 into x, or x minus y is equal to 0. Now case 2, if AB bisecting the angle between the axes, then another case is AB makes an angle 135 degree with x-axis. Then slope of AB is tan 135 degree, which is minus 1. This angle 135 degree. And C is again 0. Now equation, straight line is y is equal to mx again, because C is 0, or y is equal to minus 1 into x, or x plus y is equal to 0. Therefore, required lines are x minus y is equal to 0 and x plus y is equal to 0. We take another example. Find the equation of the line which passes through the point 3, 4. and makes intercept on the axis, the sum of whose length is 14. AB is the straight line, x-axis, y-axis, this is the origin. The AB makes an intercept A on x-axis and B on y-axis by given sum of whose length makes intercept on the axis, the sum of whose length is 14, that is A plus B is 14. Solution. Let x-intercept is A and y-intercept is B. Then A plus B is 14 or B is 14 minus A, equation I. Now, equation of a straight line in double intercept form is x by A plus y by B is 1, or x by A plus y upon B. We have B is equal to 14 minus A is equal to 1. Now taking LCM of A and 14 minus A, which is A times 14 minus A, the 14 minus A times x plus AY is 1, or 14 minus A times x plus AY is equal to A times 14 minus A, equation II. Since II passes through the point through the point 3, 4. So put x is equal to 3 and y is equal to 4 in equation II. Therefore, 14 minus A into 3 plus A into 4 is equal to 14A minus A square, or this is 42 minus 3A plus 4A minus 14A plus A square is equal to 0, or A square minus 3A plus 4A minus 14A. The minus 3A minus 14A minus 17 plus 4 minus 13 plus 42 is equal to 0, or A square minus 7A minus 6A plus 42 is equal to 0, or A common, A minus 7 minus 6 common, A minus 7 is equal to 0, A minus 7 is common, A minus 6 is equal to 0. Therefore, A is equal to 7, 6. When A is 7, required line is required line is 14 minus 7 times x plus 7y is equal to 14 minus 7, or this is 7x plus 7y is equal to 14 minus 7, 7 into 7, 49. 7 is common and cancel out. We get x plus y is 7. When a is 6 by equation II, 14 minus 6 times x plus 6y is equal to 6 times 14 minus 6, or 14 minus 6, this is 8x plus 6y is equal to 14 minus 6, 8 into 6, 48. Here 2 is common, then 4x plus 3y is equal to 48. 2 24 times. Therefore, required lines are x plus y is equal to 7 and 4x plus 3y is equal to 24. We have another example. Find the value of k so that the line 2x plus 3y plus k is equal to 0 will form a triangle with coordinate axis, that is x-axis and y-axis, with x-axis and y-axis, with area is 27 square units. Suppose this is x-axis, y-axis, this is origin, and this is AB. And the equation of AB is 2x plus 3y plus k is equal to 0. Solution. Given equation is 2x plus 3y plus k is equal to 0. Now, changing the given equation into double intercept form, or 2x plus 3y is equal to minus k. Now, dividing both sides by minus k. Or this is x by minus k by 2 plus y upon minus k by 3 is equal to 1, which is in the form x by a plus y by b is equal to 1. Which is in the form x by OA, y by OB is equal to 1. Then OA is minus k by 2, OB is minus k upon 3. Since area of triangle OAB is 27 square units, then area of triangle OAB is half base into height, OA into OB, or this is 27, 1 upon 2, OA is minus k by 2, OB is minus k by 3, or 27, the minus k plus k square, minus k into minus k, the 2 into 2 into 3, 12, or k square is 27 into 12, 324. Therefore, k is equal to plus minus 18. Okay, we take another example. Prove that x plus 2y is 0, 3x minus 4y minus 10 is 0, and 5x plus 3y minus 7 is 0 are concurrent. First of all, what is concurrent? if all lines, straight line, passes through the same point, that is, their point of intersection are same, then these lines are said to be concurrent, like L1, L2, L3, and here point of intersection is same. L1, L2, point of intersection of L1, L2, L1, L3, L2, L3. The given lines are x plus 2y is equal to 0, equation I, 3x minus 4y is equal to 10, equation II, and 5x plus 3y is equal to 7, triple I. Now solving I and II. Any two, either I or II, or II or triple I, or I or triple I. So multiplying I by 2 and adding with II, we get here multiplying equation I by 2, then this is 2x, 4y, 2 into 0, 0. Adding with II, 3x minus 4y is equal to 10. The plus 4y minus 4y cancel. This is 5x and this is 10, or x is equal to 2. 10 divided by 5. Now substituting the value of x in equation I, we get x plus 2y is equal to 0, or 2 plus 2y is equal to 0, or 2y is equal to minus 2, therefore y is equal to minus 1. Finally, substituting the value of x is equal to 2 and y is equal to minus 1 in equation triple I, we get 5 into 2 minus 3 into 1 is equal to 7. We have third equation is 5x plus 3y is equal to 7. So 5 into 2, our y is minus 1, so minus 3 into 1 is equal to 7, or this is 7 is equal to 7. True. Therefore, their point of intersection are same. Therefore, given lines are concurrent. Okay, we take another example. If P and Q are 2 points on the line x minus y plus 1 is equal to 0 and are at a distance 5 from the origin, find the area of triangle OPQ. Here, equation of a straight line, x minus y plus 1 is equal to 0. P and Q are 2 points on the line this. Suppose this is P, this is Q. Now we need to find area of triangle OPQ. solution. Given straight line is x minus y plus 1 is equal to 0. So changing into normal form, that is x cos alpha plus y sin alpha is equal to p, or x minus y is equal to minus 1. The dividing both sides by negative of coefficient of x square, so 1 is square. Here coefficient of y is minus 1, minus 1 is square, which is minus 2. We get x upon minus root 2 minus y upon minus root 2 is equal to minus 1 upon minus root 2, or this is x upon minus root 2 plus y upon root 2 is equal to 1 upon root 2, which is in the form x cos alpha plus y sin alpha is equal to p. Which is in the form x cos alpha plus y sin alpha is equal to p. Then p is 1 upon root. Now from figure, OR is equal to 1 upon root 2 by given OP is equal to OQ is equal to 5. OP is equal to OQ is equal to 5. Drawn OR perpendicular to PQ. In right angle triangle OPR, in right angle triangle OPR, PR is root over OP square minus OR square. We have OP is 5 square minus OR 1 upon root 2, and this is 25 minus 1 upon 2, taking LCM, and 2 into 25, 50 minus 1, 49 by 2, 49 by 2, this is root 7, sorry, this is 7 upon root 2. PR is 2 times of, now QR. QR is 2 times of PR. This is 2 into 7 upon root 2. This is 7 root 2. The area of triangle OPQ is half base PQ into height PR. 1 upon 2 PQ. PQ is 2 times of PR. 2 into PR. We have PR is 7 upon root 2. The 2 is root 2 is square. Root 2 cancel out. Then 7 root 2. Finally, area of triangle OPQ. 1 upon 2 base PQ into height OR. 1 upon 2, yeah, PQ is 7 root 2 into OR. OR is 1 upon root 2. The root 2 cancel. This is 7 upon 2 that is 3.5 square units. Okay, we take another example. Find the equation of two lines passing through the point of intersection of the lines 4x minus 3y minus 1 is equal to 0 and 2x minus 5y plus 3 is equal to 0 and equally inclined to the axis. First of all, given lines are 4x minus 3y minus 1 is equal to 0, equation I, and 2x minus 5y plus 3 is equal to 0, equation II. Solving I and II, we get x is equal to 1, y is equal to 1. कुनै मेथड सल्भ गरौँ, कुनै मेथड युज गरौँ र यसलाई सल्भ गरौँ त हाम्रो पोइन्ट अफ इन्टरसेक्सन x is equal to 1, y is equal to 1 आउँछ. Now your figure AB and CD passes through the point 1, 1. The point of intersection is 1, 1. And AB and CD equally inclined to the axis, that is angle OAB is equal to OBA, 45, 45, equally inclined to the axis. Similarly, here again 45, here is again 45. Now we have two cases. Case 1. If CD be the line, then slope of CD is tan 45. This is 1. Equation of CD is y minus y1 is equal to m times x minus x1, or y minus y1, we have y1 is 1, and m is again 1, x minus 1, or this is x minus 1 is equal to y minus 1, or x is equal to y. Case 2, if AB be the line, then slope of AB. Slope of AB. AB को slope यो एंगल लियो भने नेगेटिभ डाइरेक्सन हुने भयो, एन्टी क्लकवाइज डाइरेक्सनमा हुने भयो, त्यसलाई हामी नेगेटिभ मान्छौँ, र यो डाइरेक्सनबाट लिँदा एन्टी क्लकवाइज डाइरेक्सन पोजिटिभ डाइरेक्सन. सो धेरैले यहाँ स्लोप अफ एबी निकाल्दा tan 45 लिन्छ, तर एबी को स्लोप दिँदैन, त्यसले यो एंगल लिनु पर्यो 135, tan 135. This is minus 1. The equation of AB is y minus y1 is equal to m times x minus x1, or y minus 1 again, m is minus 1 x minus 1, or x minus 1 plus y minus 1 is equal to 0, or x plus y is equal to 2. Therefore, required equations are x plus y is x is equal to y, and x plus y is equal to 2. Now, angle between two lines. This is very important theorem for class 11. Angle between two lines. Let two lines AB and CD intersect at P. AB makes an angle theta and CD makes an angle theta 2 with x-axis, and angle APC is theta and angle APD is theta dash. The let AB and CD be two straight lines. Straight lines whose equations are y is equal to m1x plus c1 and y is equal to m2x plus c2. Let AB and CD intersect at P. Let AB and CD makes an angle theta 1 and theta 2 with positive x-axis. Let angle APC is equal to theta and angle APD is equal to theta dash. Then tan theta 1 is equal to m1 and tan theta 2 is equal to m2. Here AB makes an angle theta 1 with positive x-axis. So tan theta 1 gives a slope of AB. But here equation of AB is y is equal to m1x plus c1, where m1 is slope. Therefore tan theta 1 is equal to m1 and tan theta 2 is equal to m2. Then by geometry, theta plus theta 2 is equal to theta 1. Theta plus theta 2 is equal to theta 1. Exterior angle of a triangle. This implies theta is theta 1 minus theta 2. Now taking tan on both sides. Tan A minus B, formula of tan A minus B, tan A minus tan B upon 1 plus tan theta 1 into tan theta 2. We have tan theta 1, which is m1 minus m2 upon 1 plus m1 into m2. Since theta plus theta dash is 180, theta plus theta dash is 180. This implies theta dash is 180 minus theta. Taking tan on both sides again, tan theta dash is tan 180 minus theta. By cast rule, tan 180 minus theta minus tan theta. this is minus, we have tan theta is m1 minus m1 m2 upon 1 plus m1 into m2. m1 minus m2 upon 1 plus m1 into m2. This is equation I, and this is II. Now combining I and II, I and II, we get tan theta is plus minus m1 minus m2 upon 1 plus m1 into m2, because angle two lines AB and CD are theta and theta dash. Therefore, theta is equal to tan inverse plus minus m1 minus m2 upon 1 plus m1 into m2. If we take positive sign, then theta gives a acute angle, and if we take negative sign, then theta gives a obtuse. The condition of perpendicularity. Which is very important, condition of perpendicularity, that is, if two lines are perpendicular, that is orthogonal, then tan theta, then theta is 90 degree, pi by 2. Then tan 90 is equal to plus minus m1 minus m2 upon 1 plus m1 into m2. The value of tan 90, gives infinity, which is 1 upon 0 plus minus m1 minus m2 upon 1 plus m1 into m2. By cross multiplication method, by cross multiply, the 1 into, which is 1 plus m1 into m2 is equal to 0 into m1 minus m2, which is 0. Therefore, m1 into m2 is equal to minus 1. If two lines are perpendicular to each other, then product of their slopes m1 into m2, which is minus 1. Now, condition of parallelism. If two lines are parallel, then theta is 0 degree. Then tan 0 is plus minus m1 minus m2 upon 1 plus m1 into m2. Value of tan 0 is 0 plus minus m1 minus m2 upon 1 plus m1 into m2. This implies m1 minus m2 is equal to 0, something 0. Therefore, m1 is equal to m2. If two lines are parallel, then their slopes are same, equal. m1 is equal to m2. any line parallel to ax plus by plus c is equal to 0 is ax plus by plus k is equal to 0, or ax plus by is equal to k. Any line parallel to ax plus by plus c is equal to 0 is ax plus by plus k is equal to 0. के गर्ने ax plus by लाई सेम कपी गर्ने, ओन्ली यहाँ भएको c यानी कि कन्स्टेन्ट लाई के राख्दिने, के लेफ्ट साइडमा और राइट साइड जहाँ राख्ने भयो. b any line perpendicular to ax plus by plus c is equal to 0 is bx minus ay plus k is equal to 0, or bx minus ay is equal to k. परपेंडिकुलर लाइन को लागि x र y को कोफिसिएन्ट इन्टरचेन्ज र बीचको साइनलाई पनि चेन्ज गरिदिने, प्लस देन माइनस, अलरेडी नेगेटिभ थियो देन प्लस.